Alright, so now we're going to discuss a finite state machine for a more interesting plant watering controller. This one has, again, the flood and water inputs from the watering device. But now the finite state machine has two outputs. It has the water output, like we had before, but it also has the FERT output, which is going to tell us whether we want to fertilize the plant or not. Okay, so it says the operation of this device is such that if the planter is dry, the pump actuates until the flooded condition is present. We already talked about that one in the previous plant watering controller. But then it says the plant needs fertilizing every other time the plant is watered. So how are we going to incorporate that now into our finite state machine? Alright, so we're understanding the problem. It's very similar to the other one where we need to water the plant if it's dry and stop watering if it's reached a certain level, if it's flooded. And we need to now fertilize the plant every other time we water it. Alright, so there's step one. Step two is to draw the block diagram showing here we have two outputs, water and FERT, from our FSM to our watering device, and then we have two inputs, dry and flood. Alright, step three is to draw our legend. It's going to look very similar to this one. I'm going to start on a new page. We're going to have our state. And now we have two outputs. I'm going to call them water. And now, since it's fertilizer and we have a flood, I'm going to call the fertilizer output E for fertilizer. And we still have our inputs, dry and flood. Okay, so we have our legend. Step 4 is draw the idle state. So again, the idle state, we're not doing anything. We're not, call this idle. We're not going to fertilize. So we're not going to water and we're not going to fertilize. And we're going to hang out here so long as we're not dry. Okay, and now we're going to go to this next state where we want to, I'll call it water. Call it water 1 state. In this state we are going to water, but still not fertilize, because remember we only want to fertilize every other time we water. So we're going to go here if it's dry. And we're going to stay here so long as we're not flooded. Now, we want to go to now a new state. We want to go to a new state if we are flooded, because if we go back to this one, we have no recollection that we have already watered. So by starting a new state, we can remember that we already went through a watering state. So we're going to go to the idle 2 state. This is when we've reached the flood condition. In the idle 2 state, we're not going to water again and we're not going to fertilize again. But by being in this state, we've remembered that we've already watered once because we got here from this water 1 state. We're going to stay here so long as we're not dry. And then we'll go to this state, which I'll call water 2. And in this state, guess what? We're going to water and fertilize. That's when we receive the dry signal, and we do that so long as we're not flooded. And then we will go back to the first idle state when we are flooded. And so by this, we have fulfilled the requirements that we're going to fertilize every other time we water. So we watered here, then we held off, and then we watered and fertilized. And then we sat around, and then we watered, and then we sat around, and then we watered and fertilized and sat around. And it goes on indefinitely. And again, we took care of all input conditions, because as we explained last time, in the idle states we're only caring about the dry signal, and in the watering states we only care about the flood signal. And so we've taken care of every possible input combination that could happen, and we have created a complete finite state machine.